Okay, so this video is about piecewise functions. First of all, a piecewise function is a function defined by multiple equations. So for example, this is an example of a piecewise function. It's f of x, or y, is equal to 5x subtract 1 when x is greater than 1. And it's equal to x squared subtract 4 when x is greater than or equal to 1. The reason why one has an equal to power, one doesn't, so it still remains a function. It still passes vertical line test because one's going to be an open circle and one's going to have a closed circle there. Anyway, so that's what a piecewise function typically looks like. But you can have more than just two equations. You can have an infinite amount of equations here. You can see some with 3 equations, some with 4 equations, and so forth. It represents that piecewise function. All right, let's get an example. All right, so here's the first example. Example says, evaluate f of x when x is 0, x is negative 1, and x is 5. All right, so it's saying evaluate means find the value of. All right, so it's saying find the value of f of x when x is 0, negative 1, or 5. So it says when x is 0. So this function is defined in 2 places. When x is less than 2, it's defined using this equation. When x is greater than 2, it's defined using this equation. So we first got to decide whether 0 should be plugged into this equation or the bottom equation. Well, 0 is definitely a number that is less than 2. So I should use this equation. Because 0 is not greater than 2, I would not use this equation to find the value of x equals 0. So if I want to find f of 0, it relates to 6 times 0 subtract 1, which is negative 1. So f of 0 for this function is simply negative 1. If you wanted to find f of negative 1, then you have to decide which equation should I use. Well, negative 1 is also less than 2, so I still should be using this first equation. So it's going to be 6 times negative 1 subtract 1, which is negative 7. All right, and this is negative 7. And the last one says find the value of x of, well, x is 5. So x is 5 isn't here. It isn't less than 2, so I wouldn't use this equation. When x is 5, it's in this side, is on the side that's greater than 2, because x5 is greater than 2. So if I want to find f of 5, I'll plug in 5 squared plus 3. So it should be 28. F of 5. All right, so let's say evaluate piecewise functions. You determine which interval or which equation you should be using by whether the side x is defined at. All right, new example. All right, so new example. The example says graph the equation f of x equals x squared if x is less than negative 1 and negative x plus 5 if x is greater than negative 1. Sometimes I might use if, sometimes I might use when. It just depends on, it doesn't make a difference whether it says if or when there. All right, so don't get hung up with that part. But anyway, let's go actually graph it now. So the first thing I need is a graph. All right, so now we have a graph. So in order to graph this, I would think about it with a table of values. And I would think about it for each function. So this is the first function, x squared. This is going to be its table of values. And then another function, negative x plus 5. This is going to be its table of values. So I'll think about numbers that begin here, negative 1, and numbers that also go in the direction that x goes. So x is less than negative 1. You want more numbers less than negative 1. So like negative 1, negative 2, and by negative 3 it's probably going to be too big, but I'll use it anyway. And then on the other one, it starts at 1 to the right, so I'm going to start with 1. And then 2, and then 3. So if you plug in negative 1 into that equation, you will get negative 1 squared, which is 1. Plug in negative 2 in this equation, you get negative 2 squared, which is 4. The negative 3 into this equation would be negative 3 squared, which is 9. So these are order pairs, negative 1, 1. All right, so at negative 1, I got a coordinate. At negative 1, 1. At negative 2, 4, I have another coordinate. At negative 3, 9. I'm going to say 9 is about right here. All right, so this is one end of the curve. It says less than, so here where I have a dot, I'm really making an open circle. And my curve is quadratic, so I know it kind of looks curved like that. All right, so this is the left side of that curve, that little parabola. It's trying to be a part of a parabola there. Then the right side of the curve is find some outputs. If I plug in 1, I'll get negative 1 plus 5, which is negative 4, positive 4. If I plug in 2, I'll get negative 2 plus 5, which is 3. If I plug in 3, I'll get negative 3 plus 5. That's 2. And this is just a straight mark. Don't really need that there. All right, so anyway, that's what they all are. So the coordinates is 1, positive 4. So at 1, at positive 1, I got a positive 4. And at 2, 3, I got coordinates, so over 2, up 3. And then 3, 2, so over 3, up 2. And this is like a ray. Just a line with the endpoint to it. And it says or equal to 1, so I can actually include 1. So I make sure this is a closed dot, and that's an open dot. And that's the graph for it. That is the graph of that piecewise function. It is defined in these sections, as it should be. All right, so that's it. That's all I have. If you see anything, all I have for this example, if you see anything you don't already know, I'll pause the video and copy it now. So go ahead, because I'm about to erase all this. So go pause the video and copy it now if there's anything new on the board. All right, this is another example of a piecewise function. And you got several pieces to it. So we got f of x equals 1 when x is less than or equal to, when x is between 0 and 1. F of x is 2 when x is in between 1 and 2. Y is 3 when x is in between 2 and 3. And y is 4 when x is in between 3 and 4. All right, so let's graph it. All right, so it says the value of y is 1. So it's a horizontal line because you don't have an x next to it. So it's not a slant in it at all, it's just a horizontal line through 1. When x is in between 0 and 1. So this is when x is 0, this is when x is 1. So it's got a closed dot on the end here, and it goes up to 1 with an open circle. So that's the line y equals 1 on the interval. Next line is y equals 2 on the next interval from 1 to 2. So from 1 to 2 is here. So it's a closed dot and an open dot there. And then the next interval is y equals 3. So this is where y is 3. And that's on the interval from 2 to 3. So starting here at 2, you should begin at 3. And then go over to here. All right, so it's open circle there at 3. And then at 4, the value there is 4. So it goes from 3 to 4. So from 3 to 4. And that's the graph for it. It fits the description as they gave. And that's all there is to that graph. If you notice, this actually is a function. The reason why it's a function is it still passes the vertical line test. If I drop a vertical line through here where it looks like they're stacked on top of each other, it actually passes it because even though it crosses this point, because that's actually really a closed dot, it doesn't really cross there because it's an open dot, which represents a hole in the graph. So that means it doesn't exist at this spot. So it actually passes the vertical line test here, it passes it between there, and it passes at all the endpoints. So that's the reason why you wouldn't have two closed dots there. But then it would no longer be a function. This whole lesson is all about functions. So anyway, there's a name for this actually though. This is actually called step function. And I guess whoever created the name decided it kind of looked like stairs. And it's actually a function and you calculate it. If you look for it, it's actually in there. You actually can graph those. All right, last example is this. All right, this example says write the equation for the piecewise function shown in the graph below. And this is the graph below. All right, so there's two parts to this. One is this parabola here happening, and one is this little segment. it doesn't give you an arrow on the end. So I don't really know if it goes on forever. I'm going to assume it does. So I'm going to put an arrow on the ends to imply that they go on forever. All right, I'll make those arrows black. All right, got that out of the way. All right, now you want to think about how to write this equation. You really want to start off by saying f of x equals to the set symbol. But you want to start from left to right. So since this is the graph furthest to your left, you want to write the equation of this graph, all right, which is a parabola. So this is the vertex of the parabola. That vertex is here, and that's at 0, 1 vertex. And it looks like as I went over 1, it went up 1. That means that the a value equals to 1. Because if you went over and up 1 in that first interval, that means a is 1. So if you remember the equation for parabola, it was y equals a, x subtract h, quantity squared, plus k, where h and k were the vertex. So now h is 0, k is 1, and a is 1. So this equation for that parabola should be y equals to 1, parentheses x, subtract 0, squared, plus 1. Let's clean it up a bit. I don't really need to write the 1. I don't really need to write the subtract 0. So it's essentially x squared plus 1. So y equals x squared plus 1 when x is less than, and I'm not going to put or equal to bar because it's a closed dot, it's an open dot there. And that graph begins at the number 2. So less than 2. And the other section is this graph. Let's take a closer look at that graph. All right, I know there's a line, and if I extended this line, try to make it as straight as I can. I'm thinking it goes to 4. Maybe I'm wrong, maybe it goes to 3. Can't really tell, so we'll find a slope. Slope of this line looks to be fall 1, run 1. So no, the slope of that line looks to be fall 1, run 1. So the slope there is negative 1. All right, and I got a point for that graph. That coordinate is on that graph. Coordinate is at 3, 0. So I know this. I know y equals to mx plus b. And I want to know what b is so I can write the equation. So I know my slope is negative 1. And I know this is x and y. So I can say 0 equals to negative 1 times 3 plus b. So 0 equals to negative 3 plus b. So you add 3 to both sides. You get b has to be 3. So it really does go through the 3, not the 4. If you extended it. All right, so if that's true, I know the equation for that line should be y equals to mx plus b. And we decided m was negative 1. We decided b was 3. So that's the equation, negative 1x plus 3. So the other equation is, make it green again, negative 1x plus 3. And this is defined when x is greater than, if you notice, it was a closed dot there. There's a closed dot there in the original graph. So greater than or equal to 2. And that's it. That's how you can write an equation for a piecewise function by giving the graph as a picture there. This is all I have. I would pause whatever and copy down everything you have. This is all, everything you don't already know. Anyway, that's all I have. Good luck.